Yeah, welcome, and thank you for attending my presentation. My name is Alessandra Masur. I'm from Graz University of Technology, and I wrote a paper about my bachelor thesis, which has the title GrowCut under StudierFenster. Let's have a brief look at the agenda. I will start with quickly explaining some background. I will give you infos about the implementation. I will show you some results and discuss them. I will also give you a live demo, and then finally we will have a conclusion and outlook. So let's start right away with the background. My goal was to add the GrowCut segmentation algorithm to the StudierFenster website. But what is the GrowCut and what is the StudierFenster? So the StudierFenster is a website. It was done in previous work at the Technical University in Graz. It is a web-based medical image viewer that contains visualization and segmentation tools. It is based as a client-server model. It is platform and device independent because it is web-based. And the medical images that are used for the GrowCut in the StudierFenster are CT and MRI scans. Now about the GrowCut. The GrowCut is a semi-automatic segmentation algorithm. It can be used on n-dimensional images. It uses cellular automata for its computation. And an important part is that it allows user input, as it is an iterative process where users can give additional input in between the iterations. And the basic concept is that the users select some regions in the foreground and in the background, so-called seeds, and then these seeds grow until the whole image is divided into either foreground or background. And then the Fast GrowCut algorithm was also further developed. Did I say the Fast GrowCut? The GrowCut was further developed into the Fast GrowCut. There, the GrowCut algorithm was reformulated as a clustering problem, and for this, an approximation solution can be made, which made the computation much faster, as the name indicates. Okay, now about the implementation. I will show you a bit with a laser pointer where I am. So the architecture is divided into client and server side. And the client side mainly consists of the medical 3D viewer. This was already there when they developed the StudierFenster website, but I added the GrowCut menu to it and the input mask generation, and so that the input is generated on the client side, and all of this is implemented in CSS, JavaScript, and HTML. Now, the input mask that is then selected by the user and the original image are sent to the server side. The communication between client and server is done via AJAX requests. Those are handled by a Python Flask server on the server side. So the Flask server receives input mask and image, it stores it in the file system, and then it invokes the Fast GrowCut Python script. So as you see, the GrowCut in the StudierFenster the implementation is an implementation of the Fast GrowCut. That's why I was mentioning it earlier. And it is done as one single Python script. So it is located on the server because it can be computed faster and more reliable on the server. And furthermore, a Python script cannot be executed in the browser, so that's also why it's located on the server side. So the Python script takes its input from the file system, it computes the GrowCut segmentation, and then it stores the output again in the file system. From there, the output mask is loaded by the Python Flask server, sent back to the client side, and then it is automatically shown to the user in the medical 3D viewer. Now, some more about the Fast GrowCut Python script. This is more or less the main part of the implementation, so I want to add some few words. I used a Python script from the following GitHub repository and adapted it to fit into the existing architecture of the StudierFenster. This implementation is directly based on the original Fast GrowCut that was introduced, and I chose this implementation because it is very straightforward. It was already one single Python script, and therefore it was very easy to adapt it and include it into the already existing architecture. Okay, now let's have a look at some results. So this is the first result. You see a brain tumor segmentation of an MRI head scan. On the left side, you see the input, and on the right side, the output. And if we discuss it a bit, I think it was quite nicely selected, which is, of course, subjective now, but yeah. Then the next result is another brain tumor segmentation. Again, an MRI head scan, but this time a different image. Again, the input on the left side and the output on the right side. And here you see that the algorithm couldn't really decide if it wanted to include the white part or not. It was included on the right-hand side, but not on the left side, probably because parts of it were selected here in the input. And if you continue to the next result, this is a vertebral body segmentation, and this is a CT chest scan this time. And here the GrowCut was actually executed twice. So you see the first input, which has quite minimal input actually. Then the corresponding output after running the GrowCut for the first time. Then here some corrections were made. So something was deleted, colored again. And then the GrowCut algorithm was run another time, and this is the final output. And you see that it was that the output improved after running it again. So at first here, some parts were not really selected, but after the corrections, they were selected correctly. Okay, now it is time for a live demo. I hope the internet complies. Okay, let me quickly go to a browser. Yeah, no, you're still not seeing it. Now you're seeing it, perfect. Okay, so I already opened the window in the browser. This is studierfenster.icg.theograz.at. Here you see all the options in the StudierFenster, but we will go to the medical 3D viewer. I'm now selecting an NRRD file. I actually downsampled this image a bit so that the computation now will be faster. What you see here is the medical 3D viewer. So this already existed. And if we select the horizontal view, we can now go to the GrowCut menu, which I added. Okay, so this is an MRI head scan with a brain tumor that we're going to segment in this example now. So let's first select the plane that we want to segment. Maybe this one. I already selected something here that was unintentional, so let me reset it. Okay, so we will select foreground regions and background regions now. So let's start right away with the foreground. I want to select the brain tumor, then the background in a different color. I'll just go around it, make sure as much as possible is included. Here with this brush, we could delete stuff if we want to. And as you saw, you can also reset the segmentation. If we're happy with the input, I will start the GrowCut now. So I'll click on Start Fast GrowCut. And we're now waiting for the segmentation to finish. It's sent to the server, there it's computed, and hopefully the output is sent back soon. It shouldn't take too long, yeah. And now we see the output. For better viewing, we can now clear the background. So we only see the segmented parts. If we are unhappy with the segmentation, we could make some adjustments and run it again. If we are happy, we can download the segmentation. A mask is now being generated and it's downloaded automatically. Okay, that was the live demo. So we will come to a conclusion and an outlook. So as you saw in the results and in the demo, the GrowCut algorithm can successfully segment images based on a given input, but it does not always find the correct border, as we saw with the vertebral body segmentation, for example. But in conclusion, we can say that the GrowCut algorithm was successfully added to the StudierFenster, making it the first semi-automatic segmentation algorithm on the website. And users of the GrowCut in the StudierFenster now also benefit from the device and platform independency of the website itself. And using the GrowCut on the website also provides you a graphical user interface as opposed to just using the Python script itself, for example. As a for an outlook, we could allow user input in between the iterations as it was originally proposed in the GrowCut paper. Maybe this would improve the segmentation early on. We could also look into allowing 3D segmentation, because currently the GrowCut in the StudierFenster only allows 2D segmentation. And there's also the issue of handling confidential patient data, because this might be, as it is handled at the moment, it might be undesirable to send confidential patient data to a server. So we could think about alternatives for the future. And also a user study would help us to realize some flaws with the workflow or with the user interface as well. And I'm already at the end, so thank you very much for your attention, and I would be happy to answer your questions if you have any.
Sandra, so are there any questions? Okay, so we'll start here.
When you select it with the brush, you're actually coloring on an HTML canvas. So there we have a high resolution, the resolution of the website more or less. But then when you get the output, the single pixels of the input image are colored.
Okay, so the coarse resolution is the input image.
Exactly, yes. And this is a bit, you see the pixels because this was a complete CT chest scan, and I just zoomed into the vertebral body part, so that's where the resolution was got a bit worse when you zoomed in on the vertebral body, yes.
Okay, another question there.
It does. We would need to adapt the medical 3D viewer and the input mask a bit. The algorithm already allows it. And you could, I did some experimentation on the website. You could even select something like a donut. If you make a red dot, then a green circle, then red around it again, then it already notices this multi-label segmentation. But yeah, we would need to add some more colors to make a proper multi-level segmentation.
Okay, Peter?
Did you think of adding undo functionality to the brushing?
Sorry?
Did you think of undo functionality? You know, like for instance, you click on the top and then you reset the whole thing. Maybe it would be cool if you have like undo functionality, you know?
Oh, yes, I showed it quickly. We have like an eraser brush where you can erase it. Do you mean that?
Like from, you know, practically used if you do brushing, you know, if you have undo, it's much quicker, right? You can just make a story, you don't have to go and erase it.
Or like reset your last step or something?
Exactly, yeah.
That's a good point, actually, yes. We didn't think about it, to be honest, but this would be easy to implement. That's a good point, yes.
From practice, whenever I'm brushing something, like my hand faster, and these things, especially in medical field, you need to be very fast, right?
That's a good point. Yeah, thank you for. We didn't even think about it, but thank you for adding that. Yeah.
Okay, so are there any other questions? Okay, so we will thank the speaker again. Thank you.